When it comes to rendering, most people like to focus on two different things. The first thing is going to be the environments, which is going to provide lighting and backgrounds for your renders. And then the second thing is going to be appearances that use photorealistic textures, which bring your renders to life and interact with the environments and all of the lighting as well. But you'll also need to focus on the hardware that you're using too. And today we're going to talk about hardware utilization in SOLIDWORKS Visualize. Now, your presenters today are going to be myself. My name is Charn Jivaphaiboonskdi. I'm with GoEngineer, and I'm a senior applications engineer who focuses on SOLIDWORKS Visualize. And I also have on the line with me Scott Hamilton with Dell Technologies. Scott, if you want to introduce yourself.
Yeah, hi everybody. My name is Scott Hamilton. I'm an industry strategist for engineering and manufacturing at Dell, and I'm really excited to share with you our recommendations for our SolidWorks product.
Awesome. And thanks everybody for attending as well. These are a few of the topics that we're going to be covering today. And the first thing I want to introduce you to is, if you're not familiar with SolidWorks Visualize, you're probably wondering, well, what is SolidWorks Visualize? So SolidWorks Visualize comes in two different tiers. You have Visualize Standard, which is a photorealistic rendering tool that utilizes your CAD data to create magazine quality images. It's a standalone application, so creating these renders can be done in parallel with the design process, which is really nice and convenient. The best part is you may already have access to SOLIDWORKS Visualize Standard and not even know it. SOLIDWORKS Visualize Standard is available for free if your SOLIDWORKS 3D CAD Professional or Premium license is on an active subscription. Now, SOLIDWORKS Visualize Professional adds an array of features, and these include anything from animations, custom lighting, which I really like, VR capabilities, 360 interactive, and much more. It will also provide you the highest level of detail and optimized render times. And if you're utilizing SOLIDWORKS Visualize Connected, you'll have all of the same features as SOLIDWORKS Visualize Professional, which is really nice. Now, before we move on, I do want to bring up a poll to ask everybody a couple of questions. So I'm going to launch this poll. And I want you guys to take time right now to select which option best suits what is your SOLIDWORKS Visualize used within your company. I'll give you guys a couple more seconds to fill that out before closing it. Okay, great. So it looks like a majority of you don't have SOLIDWORKS Visualize, which is perfectly fine. Hopefully, this will give you some nice, interesting things to consider if you're looking into SOLIDWORKS Visualize in the future. For those of you who have Visualize Standard, that's great as well. You'll be seeing some of the professional level features here that will maybe consider you jumping into that professional tier as well. Okay. Now, when it comes to rendering, one of the biggest questions I always get from a customer is, why does it take so long to actually render an image, and let alone an animation as well? So we're going to be talking about the hardware utilization here inside of SOLIDWORKS Visualize. Now, this is what the SOLIDWORKS Visualize interface looks like if you've never seen this before. And what's nice about SOLIDWORKS Visualize compared to like PhotoView 360 is it's able to utilize both your CPU and your GPU. where Photo View 360 is only able to utilize your CPU. Now, if you want to verify the usage of your hardware inside of SOLIDWORKS Visualize, you do have to make sure that you go under Tools, Options, and then 3D Viewport. And from here, under the Render Device section, it's going to display all of the available hardware that you have available to you inside of Visualize. And you can choose to either use both your CPU and your GPU, or just your CPU or just your CPU as well. It's your choice for this. If you don't have a supported graphics card, it'll default to your CPU. And usually, if you feel like you have a supported graphics card, one of the easiest ways to make it show up on this list is just by updating your graphics card driver. That helps out a lot. Outside of that, if you don't see it again, that just means it's not a supported GPU within there. Now, for me personally, I would rather use my GPU over my CPU at any time. And when I want to verify the use of my GPU off of here, I'll want to bring up my task manager. And when you're bringing up your task manager, it may not look like it's actually being utilized, but if you change one of the charts on your GPU to showcase the CUDA analysis, from there, you'll then actually see that your GPU usage will be maximized here inside of Visualize. Especially when you click back into the live render mode, you'll see that little gap on this graph chart that you see there, that was just when I went to the task manager. When I reactivate into the live render mode, it shows that it is utilizing it, which is really nice and convenient. Now, again, I'll always choose my GPU over my CPU, and let me explain why. This image that I have right here, I've applied various NVIDIA V materials to my objects, and then I rendered it at the following settings. I wanted it to be a 4K image, so it was 3840 by 2160. My resolution is 300 pixels per inch. The number of render passes that I chose is going to be 5,000. And my render selection mode is set to accurate mode, which allows me to utilize path tracing, which is just going to give me a little bit more accurate results in the end when I'm creating my render. Now, when I rendered this out utilizing only my CPU compared to just my GPUs, that's going to have a drastic effect on the time. In fact, when I used my CPU alone, it took 8 hours, 23 minutes, and 16 seconds. And if anybody's done any rendering before, you know this isn't uncommon, especially when it's utilizing a CPU. You're going to have to just let it do its thing and go away from the computer and not want to touch it because your computer actually becomes incapacitated within the rendering. So what I ended up doing here was I started this at the end of the day, decided to go home, came back the next day, and I was able to see how long it actually took to render this on my CPU when I got back to the office the next day. So pretty unrealistic to try to do this with a single image, but watch what happens when I change it over to just my GPU. Now my laptop is running the last generation NVIDIA Quadro RTX 5000, and with the GPU alone, it took 30 minutes and 52 seconds. And you can see that even with the last generation NVIDIA GPU, 30 minutes is a lot more manageable than 8 hours to render a single image. In fact, I can render out multiple images throughout the day while I'm at work, and even do this while I'm in a meeting and come back right after the meeting, and it's more than likely going to be done. Now, NVIDIA has also recently released their newest Ampere architecture GPUs, and they've released an NVIDIA RTX A4500 GPU, which is utilizing the latest Ampere architecture. And when utilizing a single RTX A4500, the render time for this same image was reduced down to 14 minutes and 9 seconds. So these leaps in technology that they're doing over these last few generations are becoming significant in helping to reduce the render times, which is really amazing, especially because of how long renders can take for animations and how often I do renders as well. I'm able to notice this information. Now, if you have a computer that can utilize multiple GPUs, SOLIDWORKS Visualize can take advantage of multiple GPUs. And when you have multiple GPUs, it's basically going to pool together the CUDA cores, the ray tracing cores, and the tensor cores that you're going to find on newer NVIDIA GPUs. Um, when I'm rendering this with a dual NVIDIA RTX 4500, this image was rendered in 7 minutes and 1 second. So significant, and it's really a linear progression when you have multiple of the same GPUs, which is really nice. Now, this is again with one image. Imagine the time savings you'll see when you're rendering out an animation, which can consist of hundreds of images that represent a single frame. So we can see that using a GPU will greatly reduce your render times over a CPU. And with each GPU generation advancement, NVIDIA is actually able to help continue in reducing the rendering time as well. So try to get like the latest to help you with your renders if you can, because the technology is just escalating high. Now we can see that like these are the reductions from a CPU down to just a GPU was a 93% reduction. And even with this latest generation of architecture, I'm able to reduce it down to 97% reduction for a single A4500, which is really amazing from what I've seen and tested. Now, NVIDIA works closely with SOLIDWORKS to help optimize their GPUs for designing and SolidWorks. For the manufacturing industry, SolidWorks is an industry standard for CAD applications that takes full advantage of the NVIDIA RTX to speed up the product design and workflows. SolidWorks benefits from the large memory of the NVIDIA RTX GPUs and the high performance to deliver a fluid CAD experience, even with the largest models and assemblies. And NVIDIA RTX even provides performance needed to dynamically review these models in VR. So when you're using e-drawings for that, you'll be able to use these GPUs for that. Now, SOLIDWORKS Visualize lets you take your CAD models a step further by rendering with photorealistic quality thanks to ray tracing and AI denoising technology. As a designer and engineer, being able to accurately visualize every component in the design process leads to a more efficient review that better matches the real world output of the products that we're creating. This alone can save an immeasurable amount of time, but what you can see with NVIDIA RTX is up to a 3 times faster on a desktop workstation than the previous generation, and up to a 7 times faster progression when using a laptop GPU, which leads to significant costs and time savings in the long run for everything. Now, everything that I've shown you so far is included with SOLIDWORKS Visualize Standard. But if you're dealing with a laptop, you're extremely limited on the upgrade capabilities for a laptop because the GPUs and the CPUs are usually soldered to the motherboard. So you're not really going to be able to upgrade those at any time without having to buy brand new hardware. So how else can we reduce render times? Well, if you have SOLIDWORKS Visualize Professional, this will give you access to what's known as SOLIDWORKS Visualize Boost and Power Boost. Both Visualize Boost and Power Boost will offload the rendering to other computers to help reduce the amount of time it takes to render your images and animations. And both are incorporated with each license of Visualize Boost. Now, when you're utilizing the live render mode, Visualize Power Boost is what you're going to enable through your render selector. So you'll just have to go to the render selector and you'll see this fourth icon that will give you access to Power Boost. And this will help you set up your renders a lot faster when you're applying materials. You can offload the information to other computers to help scale all of their GPUs and then see the renders come into play while you're setting this up much faster. Once enabled, you will have to look at the GPU usage in the task manager. Notice how it's not looking like it's actually being used on my system anymore. And that again is because I'm actually able to utilize my desktop computer that's sitting right next to me to offload my render to that computer and use whatever hardware I have available on there. And it acts as a boost cluster for me, which is really nice and convenient. If I remote in, we can actually see what's going on my desktop computer. So here you can see that I've set up my render device to only use my GPUs. In fact, I have two NVIDIA RTX 4500s. And I can choose whether or not I want to allow one of them or both of them. Now, when I go in and change the task manager onto my home computer, notice that both charts I have to switch to a CUDA graph, but I'm able to see that it's utilizing all of the horsepower from those GPUs on my home computer and allowing me to not use as much on my laptop for it. So really nice and convenient. You can basically set up a cluster of computers to help offload it. In fact, that's what a lot of these movie production companies are doing when they're creating renderings. They're using server farms that can help offload this. And Visualize has that capability, again, with SOLIDWORKS Visualize Boost. Now, when you eventually see a sharp drop in the GPU usage, that again, it just means that the rendering is completed or it's not being utilized. So here we can go back in and actually switch back into my laptop to see what's actually going on within there. So if I switch back over, just minimize my remote session, and you can see it hasn't been doing anything for several minutes while we've been talking. Now, in order to be able to use SOLIDWORKS Visualize Boost and Power Boost, you do need to make sure that you've configured your Boost cluster. Once you've configured the Boost cluster on the computer that you're setting up your SOLIDWORKS Visualize render, you'll need to connect to the cluster by going to Tools, Options, and Boost. If you have SOLIDWORKS Visualize Professional and you haven't set up Boost, go ahead and check out our website, GoEngineer.com. You can find some blog posts that we've created that will walk you through how to set that up. And if you have any questions or issues, feel free to reach out to our technical support team, and we'll be more than happy to help you get that configured. Now, again, when you're in the live render mode, this is only utilizing SOLIDWORKS Visualize Power Boost to help you set up your render a lot faster. When you're ready to actually output the final render, under the render settings, this is where you're going to see that it does allow you to choose SOLIDWORKS Visualize Boost in the render selection. Again, when you're using the final output render, this will free up your hardware so you can continue using your laptop to set up another Visualize render or any other tasks that you're required to do. And it's all, the render itself is just being offloaded to another machine to use all of their available horsepower. Now, what's nice too about Visualize Boost is every seat of SOLIDWORKS Professional comes with one seat of Visualize Boost. But if you need to buy additional seats of SOLIDWORKS Visualize Boost, every computer that you want to add onto a cluster needs to have its own Visualize Boost license to add that computer to it. You can buy additional seats of SOLIDWORKS Visualize Boost to add on to your cluster. And again, Visualize Boost is only available in Professional for Visualize. So you'll need to make sure that you upgrade to Visualize Professional before you can even start using Visualize Boost. Okay. Now, that's basically the hardware utilization here inside of SOLIDWORKS Visualize. Now, if you're just getting started with SOLIDWORKS Visualize or you're in dire need of an upgrade, Let's switch over to Scott, who's gonna show us some of the recommended hardware that Dell Technologies offers for our customers.
All right, excellent. All right, thank you, Charn, for the great introduction. I'll dive into the details of the recommended hardware for SolidWorks Visualize and SolidWorks in general. But before I do that, I want to talk about different workloads that we typically see on workstations. And this is really important because when you buy any workstation, you want to make sure that the workstation is really going to meet your needs. And Charn touched on a couple of items there, that you need to be concerned with, CPU or GPU. Of course, there's memory and there's all kinds of other parameters that we look at when you are using an application such as SolidWorks. And really, we break those two workloads into two different types: interactive work and computational work. And really, the difference between those two types of workloads is interactive workloads tend to be what we would call kind of bursty in their demand. So the reason for that is when you're interacting with the system, for example, in standard SolidWorks, when you're doing part modeling, there's lots of periods of time when you're thinking and you're not really inputting anything in the computer. And then when you do input something, you want it to get to, update that, calculate, update the display as quickly as possible so you have a very interactive experience, right? And that's super important because we all know as you're doing design work, the faster the computer responds, the more productivity you will gain from that, because we all know when you start something and then you have to wait for it to finish, you kind of lose your focus and get distracted. If it's really slow, maybe you even go get a cup of coffee, right? So that interactivity is really important. And a computational workload is very different. This is much like rendering in visualization, SOLIDWORKS Visualize, or using the simulation and analysis modules, where once you set something up, then it requires generally a lot of computational cycles. And, at that point, you push the button and let it run. It's a batch process, essentially. And those two workloads will actually typically exercise or put different demands on the system. And you can see this is the example of the interactive workload in green. And you can see as you get further to the outsides of this radar diagram, those things that are really peak the system. So CPU turbo frequency is really important to give that quick interactivity. GPU rendering performance when you're spinning your model around. Memory speed when you're loading the model into the system. And also sequential storage performance, again, when you're opening a model, reading it off the disk. Those type of things are really important when you're using interactive workloads. Now, let's compare that to a computational workload, and you can see the demands are very different. Usually it's CPU core count or GPU computational performance. Memory capacity is important on both the GPU and the CPU. So you can see it really puts different demands on the systems, and we can compare them, and you can see those different demands and how the different workloads will push your computer. So out of that, it's really important to understand, what demands are going to be put on your system, and consider building a balanced system, okay, that's going to meet the demands that you're going to put on it, right? You don't want to, for example, use a dragster when you need to make turns, right? Or, you don't want to have a bicycle when you want to go super fast, right? So different considerations for different use cases. And especially, this depends on what software, your application, and your workflow that you're using. And not only do you want to consider just SOLIDWORKS, maybe you're using other applications as well. It's pretty typical that an engineer would use other applications besides just SOLIDWORKS in the workflow. So make sure you consider that when you're buying a workstation. Concurrency is another thing to consider. And this is, are you going to be doing multiple tasks simultaneously? For example, are you going to run SOLIDWORKS Visualize and do a rendering in the background while you're trying to do some part modeling at the same time? So keep that in mind, because now you're doing two things at once, and that will put extra demands on the system. So you might need a few more CPU cores. You might need some extra memory to make sure you can load all that stuff at the same time. And then future needs and expandability. This is really important. So we all know that our models, our designs are not getting simpler, right? It's only getting more complex. So think about what your needs are going to be in 2 or 3 years, and, buy a system that's going to meet those growing demands. And then, the expandability is important. On a tower system, it's easy to change components, add more memory, swap a graphics cards. But remember, as Charn mentioned, if you're using a mobile system, those have limited expandability. So consider that when you make your purchase, and make sure you consider what your needs are going to be, knowing that you can't change all the components. All right, so let's dig into the details. What are our recommendations for CPUs? Now, I've broken these slides into 3 different areas. SOLIDWORKS standard use cases, so that's your basic, part modeling, assembly, the typical workflow. For simulation, so this is if you're using some of the simulation modules, whether that's fluids or mechanical, stress analysis, or SOLIDWORKS plastics even. And then there's Visualize. So each one of these has different requirements. I'll focus on the Visualize one for today, but just know that there's some recommendations in here for the other use cases as well. So for Visualize, what we like to see is something above a 3 gigahertz turbo speed on the CPU. That's to keep that interactivity up, and also to be able to load all the data from the CPU into the GPU. And then, and that usually means you want to have 4 CPU cores for GPU accelerated renderings. If you're going to use CPU only, then you probably want 8 or more cores, right? Because you don't have that GPU acceleration. But as Charn mentioned, we highly recommend you do GPU accelerated rendering, because you can see the performance gains you got from Charn's slides. So it's pretty dramatic. As far as RAM goes, for Visualize, usually 32 gigs is plenty. So that's kind of the same as what we would recommend for standard SOLIDWORKS use cases, okay? Pretty easy. If you're doing simulation, we might recommend some more, because that does tend to be very memory intensive. But for Visualize, 32 gigs is usually very good. And then storage across the board, really. SOLIDWORKS always recommends SSD, okay? And just an FYI, there's 2 types of SSDs that are available typically these days: SATA-based or NVMe-based SSDs. We highly recommend the NVMe ones, because those can be quite a bit faster than SATA-based SSDs, but both will work. But, we recommend those because better performance on the NVMe. And, historically, there was a pretty big price difference between the 2 different versions. Nowadays, that's pretty much gone away. So for maybe a very, very slight price increase, I would recommend the NVMe SSDs. Now, the GPU, this is the most important for Visualize when you're doing GPU accelerated rendering. So for standard SOLIDWORKS users, I would typically recommend an NVIDIA A2000 or A3000 class card. That's usually very good unless you have extremely large assemblies or something. Then you might want to go up a level. But the requirements for Visualize are very different because Visualize is GPU accelerated. The higher end GPUs that you're seeing here, the A45, A55, and even A6000, will give you very significant performance gains for Visualize. And, as Charn mentioned, if you use the boost feature, you can use, multiple GPUs across a single or even multiple machines, so you can really increase that performance. And this is very, very important. Maybe most people that haven't used Visualize or any rendering software may not realize this, but you might say, oh, well, I only render, once or twice, occasionally. But when you think about it, in reality, every time you create a single rendering, for a project, or, maybe you have to share it with your manager or a customer or something, as you're rendering, you're probably going to render it, 10, 20, 30 times before you get the image you really want, for that one final result, because, you got to get the colors right, you got to get the lighting right, the perspective, all that kind of stuff, you got to get it right. So you never get the rendering you want the very first time. So, typically you're going to render many, many, many times before you get your final rendering. And, every one of those renders that's accelerated is going to really help. Imagine, in Charn's example before, when he talked about using the CPU and it took 8 hours. Well, every time you make a change, you got to, wait 8 hours to see the final result, right? And so that can be very time consuming if you have to make 20 changes, 20 times 8, that's a long time. Now, I will, if any of you that have used Visualize, it does use this progressive rendering algorithm, that it does give you a preview of it and it refines it over time. So you don't really have to wait the entire time, but still having that more interactive and quicker rendering will give you dramatic benefits.
Yeah, and when it comes to animations too, it's not uncommon for that to take days, depending upon the number of GPUs you have. So the more you have available to you, I've reduced some down from like 100 hours to 5 hours, just with multiple GPUs, and it helps out a lot.
Yeah, that's a great point, Charlie. Because just remember, when you're doing an animation, you're rendering, whatever, 30, 24 frames for every second of your animation on the video. So the number of images that you're rendering goes up dramatically. Okay, so now we talked about what the needs are. Let's just take a quick look at what the Dell Precision product family looks like, and I'll run you through a couple of different scenarios here. So first of all, we offer 3 different form factors: mobile, tower, and rack. And obviously everybody knows what a mobile system is. These are great for when you need that mobility to move around, whether it's within the office or between the office and home. This has been, of course, increased by the days of COVID, where, people had to work from home. And I think a lot of people are still in a hybrid mode. So mobile systems are very, very useful for that. Our tower systems are the typical ones that sit at your desk. And these will, of course, offer, more power, full features, more expandable and all that kind of stuff when you really need a lot of horsepower. And then we also offer rack workstations, which are really interesting because these are essentially like a tower workstation as far as, feature sets, but they come in a rack form factor that allows you to mount it in a machine rack or put it in a data center. And then you connect to it remotely using PC over IP technology. And the benefit of that is now you remove the system out of your working space, so you have you don't have a computer sitting at your desk.
you still have your mouse, monitor, and keyboard. You also remove the heat and the noise out of your working environment. So that's a really nice feature, right? And then you can connect to it from work or connect to it from home. You don't have to really carry anything with you. Just have a mouse, monitor, and keyboard at home and at work, and you can just connect to it remotely. So that's kind of a nice beneficial feature, pardon me, of the rack workstation. And you can do that with towers as well. So if you want to have the tower in your office, at your desk, and then at home remotely connect into it, you can do that as well using the same technology. Now, we also break up the workstations into three different series, 3000, 5000, and 7000. And these are 3000 are kind of what we would consider entry-level workstations. Many of these are quite powerful and will run SOLIDWORKS and Visualize very, very well. Our 5000 series are more of our little bit more performance, more mainstream. And then our 7000 series are the maximum performance workstations, okay? So if you're doing for Visualize, if you really want maximum rendering performance on a mobile system, I'd recommend one of these two here for mobile. And then, you know, here in the towers, you can add 2 or even 3 high-end NVIDIA graphics cards into these towers in the rack to really get extra rendering performance there. But all that being said, like a 3660, you can still put up to an NVIDIA A6000 GPU in that machine, and it will work quite well for Visualize or SOLIDWORKS in general. It just won't allow you to put multiple, you know, big NVIDIA GPUs in there. So, you know, that's probably fine for most people, but if you want that extended power, you'd look over in this area, okay? All right, so just a couple of notes. So for additional information on selecting the right workstation, we have an article here that you know, GoEngineer wrote up to help give you guys some additional guidance. It goes into a lot of detail. So I'd encourage you to look at that. And by the way, we'll, you know, make this presentation available to you guys. Also, we have the GoEngineer and Dell Expert Network program available. And this is really good because you can go to that URL, just dell.com/GoEngineer, and we have a special 10% discount for you guys. So if you buy through this website, not only will you get the standard discount that Dell offers, you'll get an additional 10% discount off of certain configurations. So that's a great bonus. And on this page, we have recommended configurations. So it will tell you exactly what to buy. And if you look at this closely, I know you can't really read all the detail in here, but there are some blocks of text right here, descriptions of the use cases. So, you know, read those and make sure, you know, you're buying the one that aligns with your use case. So if you're going to use SOLIDWORKS Visualize, make sure you pick the ones that, you know, mention SOLIDWORKS Visualize so you get the right configurations. And then there's also a contact on that page. If you have any questions about configurations or how to buy it, there's a contact. Akshay here is actually, there's a new person that's on the web page. This is a little bit older screenshot, but there is a new contact there if you have any questions. And then we also have Dell Financial Services available. I'm not going to go through all these details here, but just want to let you guys know that that is available. So, you know, if you want to finance your workstation purposes, you can certainly do that. Okay, and then here's some more information, useful links that you might find helpful. Our Dell Optimizer tool will help you optimize your workstation performance. Hardware certification. So just to let you know, that's a page where we list all of the certified configurations for SOLIDWORKS and all the applications. So you can look up to see if your Dell workstation is certified. And by the way, every Dell workstation, precision workstation we've released has been certified with SolidWorks. Okay. We work really closely with the SolidWorks team to make sure that happens, so you can be assured that whatever workstation you buy will be certified. Our workstation advisor gives you more detailed configuration recommendations. We have this engineering and manufacturing industry guide. This is really interesting. I encourage you guys to look at that. It's an overall industry guide. It talks about what are the latest trends and solutions in the engineering and manufacturing industry. And then we have this really, really great resource called the Advanced Product Development Resource Center, APDRC. And by the way, all of these are hot links, so you can click these and go to these things. And we even have a special SolidWorks specific curated version of the APDRC available for SolidWorks users. And then there's also another article that was just recently released, how to configure the right workstation for SolidWorks 2022. And then, of course, that's the link to the Dell Expert Network page that we just looked at. Okay, so some really great resources for you guys to reference after the webinar.
But yeah, again, feel free to stick around if you have any questions. If not, thanks again for attending this webinar. If you guys ever have questions on, hardware in the future, feel free to reach out to us here at GoEngineer, and we'll be more than happy to help guide you on hardware recommendations and even provide you links to the Dell GoEngineer website as well